Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Well, guys, today's topic is the distance time graph. First of all, I am going to discuss the distance and time graph. It is a very important topic with reference to CIE examinations, as you all know. Uh, as I told you yesterday, that distance time graph or displacement time graph, displacement time graph, both are of the same type. Okay, well, so here I am telling you some major properties of speed time graph and velocity, sorry, distance time graph and displacement time graph. As I told you yesterday that in the graph, we are not concerned with the direction. That is why both the graphs look like the same, okay? Whether distance time or displacement. As I told you that distance is a scalar quantity, but displacement is a vector quantity, okay? Obviously, if we are talking about displacement, then that will be the vector, but in case of graph there will be no difference. Okay, when I'll draw, first of all, number one, if I want to show that the body is at rest, body at rest, the body is at rest initially, it means when we observed the body, it was at rest. So how we will represent? Here in the on the y-axis distance will be written, and on the x-axis time will be written. Okay, remember this. If it is distance time, distance will be along y-axis and time along x-axis, and the unit in meters, and here I am taking in second. Distance I am taking in meters and time I am taking in seconds. Okay, well, it will get clear because whenever I start writing, it gets blur. So I just wait that it gets clear. Okay. Well, now when the body is, yes, I know that sometimes whenever I start writing, it gets blur because the camera has to focus on my hand. So while focusing on my hand, it gets blur on the paper. And when I remove my hand, it again focuses on the paper. So it takes 1 or 2 seconds. Okay. Well, so that's why I leave it written like this. Well, now the first graph, which body is at rest. The body is at rest. The graph will be like this. The body is at rest initially. So I am showing it with the help of the bold black line. This bold black line is showing that the body is at rest. In the case of distance time graph or displacement time graph, here we can represent 0, or because it is the origin is at 0. So this graph will show you that the body is at rest. Well, now the second, another case of the body at rest, or we can also show like this. These two lines, whether it is like this or this and this, these two lines are showing that the body is at rest. Here it is showing that the body is initially at rest, and here it is showing that after covering some distance, the body has come to rest. So this is showing some distance covered, that after covering some distance, the body has come to rest. Okay, now the second graph, which I am going to show you, body moves with constant speed, body when moving with constant speed, body moving with constant speed, constant speed. As you know that if the body is moving with constant speed, and the direction is not changing, then it there will be no acceleration. This is the second thing. So the body is moving with constant speed. Remember this, as I told you, that when the speed is constant, then there will be no acceleration. Here it is time and it is distance. I'll take your questions. Please just wait. Let me finish the graphs which I want to make. Then later, inshallah, I'll take your question. Don't worry about it. Okay, guys, so now how I can show that the body is moving with constant speed? It will be shown with a line which is neither horizontal not vertical. Okay, this is the line between horizontal and vertical, because this is the horizontal, the time axis is shown horizontal axis, and the distance axis is shown as vertical axis. Okay, so this may be that may or may not be diagonal, but there will be a tilted line. Okay, there will be a tilted line. So it may also be something like this. If it is steepness is lesser, it means the speed is slower, the body is moving slow. And if it is more steeper, then it is moving with greater velocity. And if it is something like this, it is showing that body is moving with faster velocity. So if I am writing that A, B, C, so A, B, C all are showing you that the body is moving with constant speed. But in the case of A, the speed is highest, in B, the speed is lower, and in C, the speed is lowest. Okay, so whatever I'm telling you, it will be recorded inshallah, and this recording will be available on Edmodo after 2 o'clock inshallah. So if you want the repetition of any concept, then you can watch it again. Okay, well guys, so as I told you that this is the body is moving with constant speed, and whenever the body is moving with constant speed, there will be no acceleration or zero acceleration. Well guys, now the next thing which I am going to discuss is the body accelerates uniformly, or speed is constantly increasing, constantly increasing speed. Third one, very important graph. Normally students get stuck here, so I just want to make it clear for you. I am going to write the body accelerates uniformly, body accelerates uniformly, or we can say, or speed is constantly increasing, or speed is constantly increasing. Speed is constantly increasing. Okay, so here you can see that this is the distance in meters and the time in seconds. So here you can see that the curve like this, it is showing that the body speed is increasing constantly. There will be a smooth curve. The smooth curve is showing that the body is accelerating uniformly. Okay, now there is another curve like this. It is very important to understand the difference between these two curves, which now I am going to draw. First of all, I would like to write down that body accelerates uniformly, body accelerate uniformly, and this is basically body accelerate uniformly if uniformly, or speed is constantly decreasing, or speed is constantly decreasing. Speed is constantly decreasing. Please concentrate here. This is distance and this is time. This curve, okay? Because you can see that when this curve will become horizontal, then there will be a zero speed, because this curve is increasing. It means velocity, basically speed is increasing, speed is constantly decreasing at actually, or constantly increasing speed. Okay, now here after some time the speed will become zero. Speed was increasing, or initially we can say that after some time the speed will become zero. Well, these are the four basic graphs basically. First of all, let me see that what your questions are. Okay, okay, if the speed becomes zero, will the body come at rest? Obviously, when the speed becomes zero, the body will come at rest. Uh, okay, well. Okay. Abdullah Faisal, I think so now. I hope that you are okay with the video. Well, there was a student who was saying that his battery power, uh, uh, whose laptop battery was running out. So please, you can see the recording again. I'll repeat it again in the last if I'll get time. There is another student who is writing a question. Can we draw these graphs and email you so you can check? Yes, why not? I'll give you the work to draw these graphs. Okay. So inshallah, I'll give you some work. I'll also give you some worksheets. So don't worry about it. First of all, these are the basic distance time graph in which I have shown you that what is going on. Okay. Now, the second, another very important thing, please write it that the I have also written these qualities in my notes, which I'll upload inshallah today. I'll try to upload it today. Remember this, please write down this point if you have pen pencils, that the gradient or slope, the slope of distance time graph gives you the speed. Please write this sentence, or I am going to write in the bottom. Gradient or slope gives you the speed. Okay, so I have written that gradient or slope gives you the speed. Remember this, that gradient or slope of the distance time graph gives you the speed of the body. Well, I think so you people are aware that what is the gradient or slope, because this topic of gradient or slope has been done in mathematics class 7, also in class 8 also, and I hope that you have also done this gradient or slope in your class 9. I hope that you have done. Okay, very good. So here you can see that, as I told you in this case, that this its steepest line is A, so it is the highest speed. Here you can see that the gradient or slope is 0, because this is a horizontal line, and you know that the slope or gradient of a horizontal line is 0. Now here in the case of curve, I think so that you must be aware of. If you people are not aware, then one thing which I want to make clear, that whenever there is a curve, how we can find out the gradient? My question is this, that when there is a curve like this or like this, then how we are going to find out the gradient or slope? This is my question. Uh, there is a student who is asking basically, let me read her question actually, and just please hold your hands, please. Okay. Location point in the graph. Okay. Well, by selecting points on the graph. Okay. I'll tell you. First of all, let me read the question of one student who is writing. There is a student who is writing. I'm repeating the question, reading the question of that particular student. Doesn't gradient give acceleration to? Gradient gives acceleration. Actually, bache, whoever has written this question, I'm not mentioning the name. I told you that the gradient of distance time graph. I am talking about the gradient of distance time graph. The gradient of the distance time graph gives you the speed. We are talking about the distance time graph. Okay. So when we will discuss the velocity time graph now, then the gradient of the velocity time graph gives you the acceleration. In that case, I'll explain you, inshallah. So please concentrate to my words also. Okay. Okay. Actually, in math, you have already done the speed time graph or velocity time graph. In the case of speed time graph or the velocity time graph, the gradient of those graphs gives you the acceleration, which we are going to study later. But here, this gradient of the distance time graph or displacement time graph gives you the speed or velocity. Speed or velocity. If I am saying that displacement time graph, then obviously I'll use the term velocity. If I am talking about distance time graph, then I can use the term speed. Okay, now the question which I put before you, that how we can find out the gradient of a curve. So remember this very basic thing which you will do also in mathematics, that whenever you are going to find out the gradient of the curve, you have to draw a tangent line. I don't know whether you people are aware of the word tangent to the curve or tangent of a circle. First of all, let me explain you the meaning of tangent of a curve. Tangent, T-A-N-G-E-N-T, tangent of a curve. Well, guys, those who are aware of this tangent of the curve, it's okay. But those who are not aware, let me clear them that if I have a curve, suppose this is the curve, and I have to find out the gradient of this curve at a particular point. Remember this, if this is the curve, then its gradient will change, its slope will change on at every point. Here the slope will be different, here the slope will be different. This is point A. At point A, the slope will be different. At point B, the slope will be different. At point C, the slope will be different. So I have mentioned 3 points on the curve. So as you know that on the curve or on a line, there are infinite number of points. Okay. So here I have only chosen 3 points A, B, C, at which I have to find out the gradient or slope. Okay, as for the tangent of the curve is concerned, so remember this definition of the tangent of the curve. Tangent, for example, if I am drawing a circle, okay, you know that curve is also a part of the circle. So if I draw this line, this is the straight line. This straight line which is touching the circle as a single point. The straight line which is touching a circle at a single point is called tangent to the circle. Tangent line. Okay. This line is called tangent. And remember this, tangent and radius, this is the radius of the circle. If this is the center of the circle, then tangent, this tangent line and the radius make 90-degree angle with each other. This will be done in the circle problem when you will do circle problems in mathematics. Okay, but here we are talking about tangent in a curve, and if there is a curve, I am making a greater curve to make you clear that how I am going to take the tangent. Look like this. If I have this curve, and I have to find out the gradient of the curve at one point. For example, here A is a point. I want to know that what is the speed at this particular point. So what I have to do, I must be aware of the coordinates of this point. As you know that the coordinate, because coordinate mean x coordinate and the y coordinate. Suppose here I have 5, here I have 3. Okay, so the coordinates of A will be 5, 3. I'm just taking just for example. Okay, so don't worry about it that from where 5 and 3 has come. So I am just giving you an example that how we are going to take the gradient at a particular point. Suppose this is a point A. Now what I have to do, I have to draw a tangent at this point. I am going to draw a line which is touching the curve at point A. Okay, so the line must be uh, whenever you are going to draw the line, tangent line, try that it must touch the curve at a single point. Although I have roughly drawn, so you can see that it is touching the curve at many points, but you must try that your line must touch the curve at a single point. Now you can find out the gradient of this line. This line is the tangent line. This line which I have drawn, this line is touching this curve at single point A. So this line is called tangent to this curve. Okay. Now, if I find the gradient of this tangent, that will be the speed at this particular point A. Now what I have to do next? Next, to find out the gradient of this tangent. Now my aim is to find out the gradient of this tangent. What I have to do, I have already one point A. Now I will have to find out any other point on this straight line. Suppose I have a point here on this straight line. Suppose its coordinates are 10 and its suppose its y coordinate is say it is 6, suppose. So here I am naming this point as B. So the coordinates of B are 10 and 6. As you know the formula to find out the gradient formula, y2 minus y1 over x2 minus x1, or rise over run. If you are using rise over run, I'm thinking that you people have done that chapter rise over run or formula for finding out the gradient very well. So I am directly applying the formula. I am not wasting my time because you have done in class 8 very good. So y2 minus y1 or y1 minus y2, whatever you can use. You can take both the coordinates of this point first, or you can take both the coordinates of this point first. It doesn't matter. Why? This its y coordinate is 6. 6 minus 3 and 10 minus 5. 10 minus 5. In the numerator, the y coordinates. In the denominator, the x coordinates. Okay. So it is 3 over 5. Well, guys, so here you can see that the gradient of this at point A, this is not the gradient of the whole curve. As I told you that the gradient of the curve will change at any point on the curve. If you are taking different points on the curve, then gradient will change its value. Now here at point A, its gradient is 3 over 5. I hope that you have understood this. Now there's a very important thing before the time gets over. I am telling you very important thing, that how to find acceleration with the help of speed time sorry distance time graph. You can write down that how to find out acceleration from distance time graph. How point A, it can also be gradient of B. Which actually, let me see, there is a student who is asking a question, and I think so there are many students who may not be aware of this. Actually, there is a student who is saying, I'm reading her question, how point A, it can also be the gradient of B. Listen to me, bache, all of you. If I am talking about gradient, then gradient is not of a single point. Gradient is the steepness of the line. I am talking about, it means your concept about gradient is not clear. If I am talking about the gradient of this straight line, then gradient means the steepness of this straight line at point A. So at point A, the line is this much steeper, and its value is 3 over 5. Now, if I am going to find out the gradient at this point, say this is the point C, and if I want to find out the gradient at C, that we have to draw another tangent to find out the gradient at C. Remember this, whenever there is a gradient, it is the gradient of a line, and the gradient of one straight line will be the same throughout the line, whether you are taking point A and B, or I can take any other point on the straight line. For example, if I am taking any other point like E, like F, any point on this straight line, whatever the point I can take on the straight line, I have to choose only 2 points on this straight line to apply in this formula to find out the gradient. So its value will be 3 over 5. So gradient is for the line, not for the point. My main purpose to explain is this, that there is a gradient only for a line, not for a point. Okay, the one student is writing that the point you mark one, I'm reading the question of one student who is saying that the point you marked as F, find out the gradient of that point or line. Actually bache, at this time I have not drawn this curve on the graph paper, and I have not marked these 3 and 6, 5 or 10 accurately according to the graph paper. So at this time I cannot find out the gradient using F and E because I don't have a perfect scaled graph. Okay, so when you will draw a graph on a graph paper with a full marking, then you can use any point on the straight line. Okay, I hope. Now I cannot take any approximation at this time because I don't want to waste your time. Okay, well, now my main question, my main thing which I'm going to explain within 6 minutes, that please write down this question, that how to find out the acceleration using the curve of a distance time graph or displacement time graph. It is very important to understand. For example, I'm going to show you a curve like this. I have to find out the acceleration. Find acceleration. Find acceleration. Now to find out the acceleration, for example, I must be aware of 2 points. I have to take the gradient at 2 points. Say this is a point A. I have to find out the gradient at this point. Okay, by taking, I have to, please listen to my words carefully, that at this point, and then I also have to find out the gradient at a different point. Okay, to find out acceleration. Now, say the gradient at point A, gradient at A is equal to m1. I'm not finding out the accurate value. I'm just giving you the example that after finding out the gradient with the help of this method, which I have already explained you, like I got the gradient at A, which was 3 by 5. So in the same way, you can find out the gradient at B. Gradient at B, say it is m2. So how we are going to find out acceleration? My main purpose is to find out the acceleration. So you have to find out the gradient at two different points. Now under these points you have to see that what is the time. So this time will be seen, that how much time has been passed to bring this change in the speed. So acceleration, as I told you yesterday, final minus initial. Remember this, what I told you in the beginning, that the gradient of distance time graph, this is the distance time graph. The gradient of the distance time graph gives you the speed. This is the initial speed, and here is the final speed. Final speed. So I told you yesterday the final speed minus initial speed. Final speed is m2 and the initial speed is m1 divided by time. So this gives you acceleration. This is the definition of the acceleration. Okay, I hope that you have understood that how to find out the acceleration with the help of a distance time graph or displacement time graph. I'm again telling you the method precisely, that if there is a curve and you have to find out the acceleration, then you have to take the gradient at two different points, any two different points on the curve. So as I told you that the gradient of distance time graph gives you the speed. So this is basically the initial speed and this is the final speed. At 2 points we got the speed. So final speed minus initial speed, and this time, this is the time interval during which this change in speed occurred. So by dividing these, we can find out the acceleration. Today, inshallah, I'll upload few videos and link also. Those links will also bring you to understand more things about speed time and distance time graph, because I'll upload those links, inshallah. I don't know whether you people watched yesterday's link, because those links were very important, which I uploaded yesterday. So you can see that the links are there. So here, I'll also, at this time, I'm not expecting that you must draw any graph, but you must understand all the qualities. I'll upload the notes related to this. Okay, so with the help of those notes, you can understand that how the distance time graph can be studied. Okay, the properties will also be given under these notes. Thank you so much, those who have understood, and those who have any question, they can watch this video again to make it better better understanding. So inshallah, tomorrow, the day after tomorrow, I think so, our class will be. So whenever the next class will be, inshallah, in that I'll explain the velocity time graph or speed time graph. Okay. Thank you so much. If there's any question, you can ask in the few seconds. If I'll be able to reply you, I'll be happy. For those students who are asking any question, let me see. Okay, very important thing which students have given me. Students have told me that there are almost 27 students here at this moment, and I am going to take their attendance while the class is going to finish, because as you know that attendance is very important. And okay, we have 27 students today. I don't know why the rest of the students are absent. I was expecting, because it is a very important topic, and please, those who students are absent, please make them clear that they must watch this video. Market area, one